Welcome to Systems Talk channel, where we discuss everything related to systems thinking. Since this is the first video of the channel, let us start with understanding what systems thinking is. In this episode of What is Systems Thinking, we will be covering the definition of a system, various examples of systems, what are the general properties of any system. We'll also see what is not a system. We will then look at what exactly systems thinking is. We'll further discuss about the most important law of systems thinking. We'll end the episode by talking about the books one can refer to when starting their journey of systems thinking. Before getting to systems thinking, we need to be clear about the definition of a system. The definition given by Donella Meadows says that a system is a set of things, people, cells, molecules, or whatever, interconnected in such a way that they produce their own pattern of behavior over time. So, a set of things, when interconnected, produce a pattern of behavior over time. This definition says a lot about what a system is. A system is not just one thing, but is a set of things. They are not just a set of things existing in isolation, but they are also interconnected. This interconnection makes one thing influence other things. This in turn creates a pattern of behavior over time. Let us understand what a system is with a story. Once upon a time, there was a farmer named Amar who owned a small farm. Amar had a problem. The soil on his farm was not fertile enough to produce a good yield. Amar tried using fertilizer, but it was expensive and he didn't have enough money to buy it. His friend Rohan had recently started getting a good yield, so he asked Rohan whether he will be happy to help him. Rohan was happy to help. Rohan explained that Amar could use a combination of organic waste like compost and animal manure and a process called crop rotation to improve the soil quality. When Amar asked how it works, Rohan drew a diagram on a piece of paper to explain the system. The system consisted of three interconnected variables: the type of crop grown, the quality of the soil, and the amount of organic waste used. Each variable affected the other two, and together they worked to achieve the system's purpose of producing a good yield of crops. Rohan explained that Amar could start by planting legumes to the soil because they are good at adding nutrients to the soil. Then, he could use animal manure and compost to fertilize the soil. After the first harvest, Amar could plant something else, thus preventing soil erosion to improve the soil quality. Impressed by the system, Amar decided to give it a try. After the system was implemented, his farm got a good yield of crops. Amar was grateful for Rohan's help and was happy with the system that he had implemented. According to Donella Meadows, a system must consist of three kinds of things to be called as a system: elements, interconnections, and function or purpose. So, a system has elements which are interconnected that generate a function or purpose. We already saw how this definition works with the story of Amar and his farm. The system which Amar implemented consisted of three interconnected variables: the type of crop grown, the quality of the soil, and the amount of organic waste used. Each variable affected the other two, and together they worked to achieve the system purpose of producing a good yield of crops. Let us see few more examples of systems to understand this definition. Take for instance a forest. What are its elements? They are trees, animals, insects, birds, rain, fungus, etc. The interconnections are of laws of nature by which everything works in the forest. Animals interact with trees by eating fruits and vegetables. Animals eat other animals. Fungus gets nutrition from dead trees and animals. Trees get nutrition from fungus. These interconnections give rise to a function or purpose to the forest. The forest, because of the presence of so many trees, manufacture oxygen for the planet. The planet thus becomes habitable. A city is a system. the elements of which are buildings, people, transport, restaurants, offices, etc. People here go to office by using public transport. People go to restaurants to eat. There are people who construct buildings, and then there are people who live in those buildings. The city thus creates a purpose. One of the purpose is to provide livelihood to people. One of the examples which Donella Meadows gives in a book, Thinking in Systems, is that of football. The elements in a football team are players, coach, field, ball, etc. The interconnections that happen are rules of the game which make sure that the game is structured. Coach's strategy which takes the team towards winning. Laws of physics that drives the motion of the ball. The function or purpose of the football team is to win games or make money or exercise or all of the above. After understanding what a system is, we need to understand what is not a system. A random collection of objects is not a system. For example, sand lying on the road is not a system, as taking away some of the sand is not going to make much of a difference. You will end up with as much sand on the road. Anything that lacks clear structure or defined set of inputs and outputs, thus lacking a purpose, may not be a system, as it is going to give unpredictable behavior. Thus, from the examples above, we can derive the properties of a system. A system has clear boundaries. A football match takes place inside a stadium. System maintains integrity or wholeness, and there are mechanisms in the system that maintains that integrity. Systems are dynamic as the behavior changes over time. New players are added to the football team, the coaches change, etc. Systems can be self-organizing and are resilient to disruptions. A forest as a system can occur on its own if given millions of years, and it is resilient to disruptions such as heavy rainfall or floods. All systems have feedback mechanisms in place. Without feedback, a system will not improve and eventually perish. A football team will make necessary changes after losing a match, otherwise, it will lose its ranking. Now that we have understood what a system is, let us understand what systems thinking is. There are many definitions available on what exactly systems thinking is, but this definition by Peter Senge covers everything systems thinking is. Systems thinking is a discipline for seeing wholes. It is a framework for seeing interrelationships rather than things, for seeing patterns of change rather than static snapshots. So as soon as we start seeing relationships rather than the things inside them in isolation, we become systems thinkers. Because only by observing the relationships and how one variable affects other variables will we be able to understand how the system behaves over a period of time. We start seeing patterns that emerge out of the system, which only is possible by seeing those interconnections. Once the definition of systems thinking is clear, it becomes easy for us to understand one of the most important laws of systems thinking, that is, structure influences behavior. So, as a systems thinker, we see the components of a system and the relationship defining a structure which gives rise to a behavior that has some purpose. For example, we are not going to see players of a football team in isolation, but we are going to see the entire system of football having variables including the coach, players, referees, etc. Only by looking at the system as a whole, the football team will be able to take better decisions, which will help the team to achieve its purpose of winning. We already saw this in the story of Amar and his farm. The structure and the relationship between type of crop, amount of organic waste, and quality of soil drove the system's behavior of making the soil fertile to get a good yield. Only when the system was well understood and implemented by Amar that he was able to achieve the results. Following are the books referred to create this episode. Both these books, Thinking in Systems by Donella Meadows and The Fifth Discipline by Peter Senge, are necessary to start your journey of systems thinking. To summarize, We started by understanding what a system is. We saw various examples of a system. We looked at the properties of a system. Then we also discussed what is not a system. After this, we saw the definition of systems thinking and covered the most important law: structure creates behavior. Thank you for watching this episode. In future episodes, we will go in depth to understand various concepts of systems thinking.